Dear students, welcome back. So I am going to continue the exercise 5.1, in which 8th question, that is f of x is equals to modulus of x divided by x if x is not equals to 0. Because why it is not x is not equals to 0? If x is equals to 0, the function not defined, and the value of the function is 0 when f of x is equals to 0. So let us consider the function f of x is equals to. So convert this function into standard form. That is, we have here, we know that modulus of x is equals to plus or minus x. Okay. So the function is modulus of x divided by x. When we take only plus x, that is x by x. Modulus of x is equals to only plus x. That is 1. When you take minus x, modulus of x divided by x is equals to minus x divided by x. This is minus 1. So that we have two values. This is 1 for if x is greater than 0. This is why we say x is greater than 0. Here x is less than 0. When plus x is when x is greater than 0. Minus x is when x is less than 0. So here 0 when x is equals to 0, and minus 1 if x is less than 0. So this is a new function. This function is converted into this form. So now this is nothing but a signum function. What is this? Signum function. So you already familiar about signum function because you already studied about this in class 11th. Signum function. The graph of the signum function is nothing but is like this. This is a Cartesian plane or xy plane. Y axis, x axis 0. Here 1, 2. Here this is minus 1, minus 2. What happens here? When x is equals to 0, 0. The function is 0. When x is greater than 0, the value of y is the function is 1. Okay. This is excluding 0. This is excluded. The function travels in this direction. When x is less than 0, the value is minus 1. It travels in this direction. So here, this is the signum function and this is the graph of the signum function. What happens here? Can you draw the graph at one sheet? No, because the function travels in one direction. Here it is travels in another direction, and here the huge gap, so that we can't draw this graph at a one sweep. Means what is continuous function? If we draw the any graph without lifting a pen or pencil, then it is called as a continuous graph. But here this is not continuous. It is a breakage. It has a breakage here. Hence this is a signum function. Hence this is not a continuous. So that how we can prove this example? See here. So here also the function is in pieces. Hence we use the identity limit as x tends to c minus c equals to limit as x tends to c plus equals to f of c. So that first one, LHL, limit as x tends to c minus f of x. Limit as x tends to 0 minus, because the limit is 0 here. On that occasion, left hand limit for x is less than 0, that is minus 1. That is a minus 1. Hence the value is minus 1. LHL is equals to minus 1. Similarly, RHL is equals to limit as x tends to c plus f of x. Limit as x tends to 0 plus, the function is when x is greater than 0, means for right hand limit x is greater than 0. For right hand limit x is greater than 0. For left hand limit x is less than 0. So in this occasion the function is minus 1, but in this case the function is 1. 1 only. Yes, this is 1. So the value is 1 here. This is RHL. And here observe that LHL and RHL. Here LHL is not equals to RHL. The limit does not exist. Hence the function is not continuous. At x equals to 0. What happens here? At exact x equals to 0, the function is discontinuous because it has huge gap between this and this. Because if it is like this, we say that this is a continuous term. Because here there is a huge gap between -1 and +1. Exactly at x equals to 0, the function is discontinuous. Hence, this is a discontinuous function. Yes, student. Next question is in the exercise 5.1, that is the 9th one. That is solution. Let us consider function f of x is equals to. So we can write this function as here x divided by modulus of x. So here modulus of x is equals to plus or minus x. Okay, this value is plus or minus x. So when x is the value of modulus x is minus x, that is divided by minus x is equals to minus 1. And here also, because only we consider the negative x, because since x is less than 0, only we consider negative x. Hence, only we put here the value of the modulus of x is minus x, but not take the plus x, because the value of x is less than 0 here. Hence, we can write the function x by modulus of x as minus 1. This is minus 1 when if x is less than 0. And here also it is as it is minus 1 if x is greater than or equals to 0. X by minus x is equals to minus 1, because here the value of modulus x is only taken as a minus x, because x is less than 0, only we consider negative value of x but not positive. Okay, hence the modulus of x is minus x, x get cancelled, that is a minus 1. Here x is less than 0, the minus 1 is already given here when x is greater than or equals to 0 in both the cases. In left and right of the 0, the function is minus 1. Left of 0 and right of 0, that is the function is minus 1. Hence, it is a continuous function. So how we can do here? So here also limit as x tends to c minus equals to limit as x tends to c plus equals to f of c. So LHL is equals to limit as x tends to c minus f of x. So limit as x tends to 0 minus, because limit is 0. What happens when for LHL we consider x is less than 0. So yavalu LHL ಗೆ ನಾವು ಏನು ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ x is less than 0. So ಏನು ಲಿಮಿಟ್ ಇರುತ್ತಲ್ಲ less than 0, less than 1, less than 3 ಹೀಗೆ ಇರ್ತಾವಲ್ಲ ಅದಕ್ಕೆಲ್ಲವೂ ನಾವು ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಗ್ರೇಟರ್ ದ್ಯಾನ್ ಅಂತಂದ್ರೆ ಅದನ್ನ ರೈಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಇವಾಗ x is less than 0 ಅಂತಂದ್ರೆ ಇದು ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್. ಸೊ ಅದಕ್ಕೆ ನಾವು ಏನು ಮಾಡ್ತೀವಿ ಫಂಕ್ಷನ್ ಅನ್ನ minus 1 ಹಾಕ್ತೀವಿ. Okay, that is a minus 1. Hence, taking limit, this is nothing but the as it is a minus 1. Similarly, RHL. So RHL means limit as x tends to c plus. That is the f of x. What happens for RHL? We consider x is greater than 0. On that occasion, the function is minus 1. So that limit as x tends to 0 plus the function is minus 1. In both the cases, function is, so the RHL, LHL and RHL are same. Now find f of c, that is the value of 0, that is f of 0 is also minus 1 because the equal symbol is here. When f of 0 is nothing but that is minus 1, so that all the three terms are equal. X tends to 0 minus, limit as x tends to 0 plus is equal to f of 0 is equal to minus 1. Hence, all the three terms are equal. Therefore, the function is continuous. The function is continuous at x equals to 1. So the graphical representation of this curve, this function is so very simple. Cartesian plane, x-axis, y-axis, 0, 1, 2, 1, 2, minus 1, minus 2, minus 1, minus 2. So what happens? If x is less than 0, for any value of x less than 0, for any value of x is less than 0, the function is minus 1. For any value of x is less than 0, the function is minus 1. Okay, minus 1. And here also, for any value of x is greater than or equal to 0, the function is minus 1. Again minus 1. So that for any value of x is greater than minus 1, equals to 0 and greater than 0, the function is minus 1. See here, this is a constant function. This is a constant function, and we can draw this graph without lifting of chalk piece or a pen. Hence, this is a continuous graph. This is the graphical representation of this function. It means this is a continuous function. Okay. Starts. So another important question of the exercise 5.1, that is the 10th one. This is f of x is equals to x plus 1 if x is greater than or equals to 1. X square plus 1 if x is less than 1. To check the continuity of the function means find the point of discontinuity. It means it has whether it has a discontinuity or a continuity. Okay, so we are checking. Let solution. Let us consider the function f of x is equals to x plus 1 if x is greater than or equals to 1, x square plus 1 if x is less than 1. So here for LHS, here also the function is increases more than one function. Hence we use the identity limit as x tends to c minus is equals to limit as x tends to c plus is equals to f of c. If the function satisfies this condition, then it is called as a continuous function. So for LHS is equals to limit as x tends to c minus f of x. Limit as x tends to c minus, limit is 1 here, 1 minus the function. When for LHL we consider x is less than 1. LHL ಯಾವಾಗಲೂ less than ಇದ್ದರೆ ನಾವು ಆ ಫಂಕ್ಷನ್ ಅನ್ನು ಏನು ಮಾಡ್ತೀವಿ, ನಾವು ಫಂಕ್ಷನ್ ಅನ್ನು ಚೂಸ್ ಮಾಡ್ತೀವಿ. So here the function is x square plus 1, that is a x square plus 1. This is the LHL. So taking limit, what happens? Taking limit, put 1 in place of x, that is 1 square plus 1. 1 square plus 1. This is equals to 1 plus 1 is equals to 2. LHL is 2. And similarly, RHL is equals to limit as x tends to c plus f of x. Limit as x tends to 1 plus. For RHL, we consider the function which is greater than 1, that is x plus 1. X plus 1. So here also taking limit. So put 1 in place of x, that is 1 plus 1. So this is a 2. This is RHL. Okay. So observe LHL and RHL both are equal. Means limit exists. Means LHL and RHL are coincident. Therefore limit exists. Now we are moving forward to find f of 1. F of 1 means f of x. So where is equal symbol here? Here. The equal symbol exists here. And that situation we consider the function x plus 1 here. That is x plus 1. So put f of c. function is c plus 1 here. So c is what here? C is limit. That is a 1. That is a 1. Okay, 1 plus 1. This is 2. Or you can easily write directly f of x is equals to x plus 1. Easily you can, instead of writing this one, you can directly write this one. Okay. So for your better understanding, I am written here f of c is equals to c plus 1. So it is not necessary to write. So for your better understanding, I am written here. Okay. So that when you put x equals to 1 here, you get a 1 plus 1. This is a 2. So that in all the three cases, the result is 2. Hence, therefore, limit as x tends to c minus is equals to limit as x tends to c plus is equals to f of limit as x tends to 1 minus limit as x tends to 1 plus and f of 1 is equals to, in all the three cases, is equals to 1. Therefore, the function is continuous and there is no point of discontinuity. There is no point of discontinuity. Okay. So this is how we can solve this example. So this given function is a continuous at x equals to 1. So you can draw the graph. Do it yourself. You can draw the graph of this function. For x is greater than 1, the function is like this. For x is greater than equals to 1, the function is like this. For x is less than 1, the function is like that. So draw the graph. Do it yourself. Okay. Yes. Now moving to the next question, that is the 11th one. F of x is equals to x cube minus 3 if x is less than or equals to 2, x square plus 1 if x is greater than 2. So here I am going to write directly limit as x tends to c minus f of x. Here limit as x tends to, the limit is 2 here, 2 minus. So when x is less than 2, so LHL is equals to, we consider the function which is less than 2, that is x cube minus 3. X cube minus 3. So taking limit, what happens here? Put 2 in place of x, that is 2 cube minus 3. 2 cube minus 3 is, that is 8. Cube of 2 is 8 minus 3, that is 5. LHL is equals to 5. Similarly, RHL. For RHL, we consider the function which is greater than 2, and that again is x square plus 1. So that limit as x tends to 2 plus, that is the function is x square plus 1. X square plus 1. Taking limit, that is 2 square plus 1, that is 4 plus 1. This is equals to 5. So RHL is equals to 5. Now LHL and RHL are coincident. Now we are going to find f of x is equals to, what is the function here? When x is, the symbol equals to symbol exists here, and that occasion the function is x cube minus